All right, this is for CAP045. It is section 6.2, Intro to Proportions, and it is found on page 456, page 456 in your pre-algebra textbook. So last section we discussed ratios and rates and simplifying them. And now we're going to take that concept of the ratio and rates and we're going to make them equal to each other and talk about how they're a proportion. And that just means that two rates or ratios are equal to each other. And you're used to this with fractions, like 1/3 equals 2/6, right? Because we multiplied the 3 by a 2 to make it a 6, and then a 1 by the same value, a 2, to make it a 2. So it's just building up a fraction. So we could say this as a ratio, 1 is to 3 as 2 is to 6, and that would be the same. They would be equivalent. So also we could show this as 15 miles to 2 hours is the same as 30 miles to 4 hours. They just built it up by a 2 on each one, didn't they? 2 hours became 4 hours by multiplying by 2, and 15 miles became 30 miles by multiplying by 2. So they're equivalent. This is a proportion. They're proportionate. All right? So 15 miles is to 2 hours as 30 miles is to 4 hours. That's a proportion. They're proportionate. Now, to determine whether a proportion is true or not, you can use cross multiplying, which is the means and the extremes. So in other words, if you have a fraction like that, A over B equals C over D, and this is on page 456, they remind you or show you that the A and D are the extremes, and the B and the C are the means. This is just fancy math language, and it takes you to the property that the product of the extremes and the means, if they're equivalent, then it's proportionate. So in other words, if A times D equals B times C, then we know that the proportion is true. And if we try that out with our 1/3 equals 2/6 from the beginning of the lesson, 1/3 equals 2/6, if we went 1 times 6, right, does that equal 2 times 3? And sure enough, 1 times 6 is 6, and 2 times 3 is 6. And often in just regular kind of basic language, it's called cross multiplication. And you've probably done it before. So you can check out any proportion and see if it'll work. Like in example 1 on page 457, 2/3 to 7/12. Is that equivalent? Well, we would go 2 times 12. Does that equal 7 times 3? Well, 2 times 12 is 24. 7 times 3 is 21. So that does not equal. Therefore, 2/3 is not proportionate to 7/12. In the other example, in example 2, they ask, what about 4/9 compared to 12/27? Is 4/9 equivalent to 12/27? So we would go 4 times 27. Does that equal 9 times 12? So 4 times 27 is 108. 4 times 20 is 80. 4 times 7 is 28. 80 and 28 is 108. And 9 times 12 is 108. So this is proportionate. 4/9 is proportionate to 12/27. So you can use this cross multiplication technique to check whether something is proportionate or not. And the reason why you do that for a while is just then to realize that you can use some basic algebra then in proportions to find an unknown by using cross multiplication. So on page 458, in example 2, they have 3/4 equals x over 12. And so you could at least notice, like using your math thugness, that 4 times 3 is 12, so then you'd do 3 times 3 and you'd know that x is 9. But you could also use your cross multiplication to solve this. You could go 3 times 12 is 36, and that equals 4 times x, or 4x. And that now looks familiar. 36 equals 4x. You know how to solve for x. You need to divide by 4 on both sides to undo that 4 times x, and 36 divided by 4 is 9, so x equals 9. If we plug that 9 back in there and do the cross multiplication, they're going to equal each other. 3 times 12 is 36, 4 times 9 is 36. 36 equals 36. So it checks out, it works. Let's try it again with example 3. We have 3 over 2 equals 24 over n. So we're going to cross multiply. The 24 times 2 is 48, and that's going to equal 3 times n. We're going to divide both sides by 3, and n equals 16. So you're doing cross multiplication and division. Often my colleague likes to teach it to cross multiply and divide by the odd man out. And the odd man out would be the one that is across from, diagonal from the variable. So you multiply the two that are across from each other, two constants that are across from each other, and then divide by the number that is across from the variable. And that speeds things up if you just want to do calculations with your calculator. If you're setting it up and showing your work with the algebra, you'd want to set up the equation. Example 4 takes it one step further, and we get some algebra involved in the distributive property. We have 2x plus 1 over 15. That equals 1 over 3. So we're going to cross multiply. The 1 times the 15 is 15, and that's going to equal the 3 times the entire quantity of 2x plus 1. So you have to distribute that 3 to the 2x, which becomes 6x, and distribute the 3 to the 1, which becomes a plus 3. So now you have 15 equals 6x plus 3. Now you're going to do your two-step process where you use your additive inverse and subtract 3 to undo that plus 3. Subtract 3 from both sides, you get 12 equals 6x. Divide by 6 on both sides, and x is going to equal 2. If you plug that 2 back in for that x, you would have 2 times 2 is 4, plus 1 is 5. 5 over 15, does that equal 1/3? Well, 5 times 3 is 15, and 1 times 15 is 15. So yes, it checks out. All right? So that shows you how to do it with some algebra. The next example shows how to do this with solving proportion word problems, and I have a little way of showing it with a 6-celled box. So in example 5 on the bottom of 459, and then it goes to page 460, it says if you have 5 oranges that cost $1.15, what will the cost of 15 oranges be? So I teach that you make a 6-celled box, and kind of like a table. In the first column you put your units. So you put what they're comparing. So they're comparing oranges, so I'm writing oranges in that first column, to dollars. And then in the second column you write in those values. We have 5 oranges to $1.15, and then we have 15 oranges, and we don't know how much that is, so that's our x value. So there's your proportion. 5 is to $1.15 as 15 is to x. You cross multiply 15 times $1.15, and I'm going to use a calculator for this operation. 15, times 115
equal 17.25.
1725 equals 5x. I'm going to divide that by 5.
Equal 3.45.
And it's $3.45 for 15 oranges. Okay? So you can use this 6-celled box to take out all those words and put them into a very simple proportion. Let's move to example 6 and do it again. There's even more words on example 6 on the bottom of page 460. It says Dylan and David are planning a backpacking trip in Yosemite National Park. On their map, the legend indicates that 1.2 centimeters represents 2 miles. And how long is their trip if the route measures 10.6 centimeters on the map? Round your answer to the nearest tenth of a mile. So you make your 6-cell box. First column is your units. What are they comparing? They're comparing centimeters to miles. So then we're going to plug in the information. They have 1.2 centimeters to 2 miles, and they want to know how much 10.6 centimeters is going to be in miles. So notice I plugged in 1.2 for centimeters to 2 miles in the second column, and then 10.6 centimeters in the third column to x. And there's your proportion. 1.2 is to 2 as 10.6 is to x. And we're just going to cross multiply. We get 1.2x equals 2 times 10.6 is going to be 2120. And then we're going to divide by 1.2 on both sides. 21.2 divided by 1.2. X is approximately 17.6 repeated. And that would be miles. We'd want to label that MI. Okay? So you can take any story problem and turn it into a proportion just by using this 6-celled box method. Let's do one more in example 7 on page 461. It says a recipe making 2 dozen cookies requires 1 3/4 cups of flour, among other ingredients. If the baker wishes to make twice that number of cookies, how much flour is required? So let's make a 6-celled box, and we are our units in our first column. They're comparing cups of flour to dozens of cookies, right? Or we could write it dozens of cookies to cups to flour, whatever you'd like to say. It actually started out that way. It doesn't matter as long as you keep the orientation correct, but we'll just write it the way the story problem starts out with. It says dozens of cookies to cups of flour, so I'm redoing my columns, dozens to cups. So we have 2 dozen cookies to 1 3/4 cups flour, and if we want to make twice that number, that would be 4 dozen cookies to how much flour? This is pretty simple. We would probably go, well, I'm just going to double that. Many of us cook. We'd do 1 3/4 and 1 3/4. But let's look at it happening in a proportion. 2 is to 1 3/4 as 4 is to x. We're going to say 2x equals 4 times 1 3/4. You could change that to a decimal and go 4 times 1.75, or you could do the fractional math, 4 times 1 3/4. That's going to equal 7. So you're going to get 2x equals 7. You're going to divide by 2 on both sides, and x equals 3.5 or 3.5 cups of flour. So you can set it up as a proportion, or you can use your just basic math skills and realize you needed to double it. But I did want to show you how it works as a proportion. So that's the end of 6.2, ratios and proportions. You'll do a lot of practice in the homework of using cross multiplication, and then using cross multiplication to solve for x, and then applying this kind of 6-celled table method to do a bunch of story problems. It makes these story problems pretty basic when you detail them out in the table method. So that's all for now until we move on to 6.3.